So hello everyone. So I am Saptarshi Ghosh from IIT Kharagpur, and we will be presenting our project on utilizing social media for disaster relief. Let me quickly introduce the team. We have an interdisciplinary team. So myself, Pranay, Ritam, and Varun, we are from computer science. Shreyash is a designer, and Aditya is a linguist. So in recent times, in recent years, there have been many unfortunate disasters, which include terrorist attacks, floods, earthquakes, and all. And we have spoken to several people who are victims, volunteers, NGOs related to these disasters, specifically the Nepal earthquake and the Chennai floods. So we have spoken to NGOs, doctors, victims, and so on. And we have wanted to know their experience. And from their experiences, what have come out, some common points are these. So during a disaster, there is a lack of situational information and mismanagement of the relief efforts. And there is no coordination often. And so actually one of the NGOs told us this, that during the Nepal earthquake, there was enough resource available in Kathmandu, but the problem was no one knew what was required where. So these are the problems. So how can computer scientists or we help? So the suggestions were that we need, because the human forces here are in a lot of anxiety and stress, we need automated systems. So automated systems to gather situational information and automated systems which might help coordinate the relief efforts. So now the question comes, okay, so we have to get situational information, but from where? So in recent years, the trend is to depend on the people themselves who are at the disaster site. So typically to use these people as social sensors. So with the ubiquity of smartphones and internet connection and all, so social media, smartphones, these have become very important sources of information by which people at the disaster site can give information which can be utilized. So in this project, we are focusing on Twitter as a data source, and specifically we are dealing with needs and availability of resources at the disaster site. Of course, our end goal is larger, to incorporate more data sources and all, but for this project, at least for this workshop, that is what we have done. So let me give you some live examples of tweets which were actually posted during a disaster event, specifically the Nepal earthquake of 2015. So here you see some need tweets, what we call as need tweets. They talk about needs. So the electricity, water, blood donors, these are what are needed. So these are tweets, or need tweets. And simultaneously, there are the other types of tweets called availability tweets. So during these times, even before the government come in, often the local people themselves form the first line of relief efforts. So they have some availability inside that area also. So someone has water, some blood donor society, local blood donor society. So they also post tweets to inform about availabilities. So we want to automatically first we want to figure out these need tweets and these availability tweets. Now just to give you an idea, these information are very sparse. So these are the two data sets we have used during this workshop to build our programs and all. One of the Nepal earthquake in 2015, another of the Italy earthquake. If you see, the total number of tweets after removing duplicates and retweets is around 50,000 or 70,000, but the number of needs and availabilities are only few hundreds. So over several data sets that we have studied, less than 3% of the tweets are actually about needs and resources. Which brings us to the first challenge. Automatically identifying these tweets using machine learning or NLP programs is a challenge. Now, suppose we solve this challenge or we identify needs and availabilities, then what's the next logical step to match them up? So for example, we can do this. So the first tweet mentions about need for water, and the second tweet mentions about availability of water. So if these two pairs are shown to maybe the people who are coordinating the relief efforts, they can help in, or they can arrange for that match actually. So from this slide, matching seems simple. Just look for common resources. But actually it's not. Let me give you some examples. So this tweet talks about need of shelter, and this tweet talks about some second-hand tents. So for an algorithm to understand that shelter and tents mean the same, it's a challenge. What can be more challenging? These. So when disasters happen in multilingual societies like India, often a lot of tweets are posted in local languages. So the first tweet here talks about the need of khana and tent, it is food and tent, and the availability tweet here talks about tent and rice. So to match these using programs is also challenging. So the second challenge is to automatically match need tweets and appropriate availability tweets. So now that I have told you about these two challenges, I think you have got an idea of what we are trying to do. So basically you would like to build this kind of a system which would be helpful to coordinate or aid the post-disaster relief operations. We think that this system will be used by different stakeholders, like the people sitting at a control center trying to coordinate all efforts. Then people who are on site, which include victims as well as on-site relief workers. And also during such disaster times, there is a lot of help available from off-site people also, and people who are at other cities but they want to help somehow. So they are also a considerable workforce. So we want to build a system which will cater to, or which can be used by different stakeholders. Just going into a brief overview of the system, this is not at all complete, but that is what we have envisaged. So for example, there is a module for, okay, the system takes as inputs, there can be several channels of input. So from social media, then we envisage that there will be a mobile app for this system which people can directly use for input, and then commands from the control center and so on. And inside the system there would be like at least one module for identifying needs and availabilities, then modules for understanding what is needed, then matching them, and a few other modules. And we have these databases which show like the actual needs, availabilities, volunteers, and so on. And this system will have different outputs also, like the dashboard for the control center, then some interfaces for the mobile devices which are with the victims or the on-site relief workers, and so on. So I'll come back to this system at the end for a bit more. So in this workshop we have focused on these boxes or these modules. So we have spent our time working on the identification of needs and available tweets and understanding and matching them. And we have for now considered only tweets as a data source. So now I'll hand it over to the team members. So Pranay will talk about the identification of needs and availabilities. After that, Rhythm will talk about understanding and matching. And Shreyash, the designer, would talk about sample interface design for this system. So over to Pranay.
So my work was focused at retrieving from the last set of tweets which are specific to a need and availability, and know that if a tweet is a need tweet or an avail tweet. So the first work that was done by a lot of people was using pattern matching techniques. You can see that a lot of patterns can match nice tweets, but the problem with this that there are total 953 patterns if we want to cater to a large set of tweets. And the only problem with this is, even though I recall, which is of the total number of tweets that are relevant, we are able to find 70% of them. But if we take a given set of tweets, we will see that only a very few of them are actually relevant, because these patterns are so diverse, they match to more than what is relevant in that data set. So we build our own retrieval and search system. What this tries to do is that on seeing the data, it matches a model, it creates a model which will help us work with the underlying structure of the language in the tweets. Using that and a query which we choose, for example, an initial query for the need tweets can be need and require, just these two words. And we rank the tweets according to the similarity of the query with the set tweet. And from these, we choose top K tweets, let's say 10, and out of those 10, we choose 3 terms which we think will help us refine our query, which is more relevant to need and requirement or availability, as the case may be, and we expand our query. Hence, we have refined our query to our data set, and then we do the whole process again and we retrieve those tweets. And so this is our basic model which we use. So the first would be to use a language model. So we experiment with the information retrieval tool called INDRI, which uses topics over on the queries to do this. We see that the precision is quite low, and the recall is also even like just 30%, which is not at all good enough. We want to make disaster relief better. So some other limitations of these methodologies are that they cannot differentiate between the need tweets and the avail tweets. They just do, when they retrieve, they just retrieve on the basis of things like what they're offering. So, and a lot of people can covertly express their requirements. Like one of the examples would be, we are out in the open, we need shelter. So this is overtly expressed, but some people can just say we are thirsty. this doesn't tell you much, right? So we try to model this using neural networks, deep neural networks. This is a good problem for machine learning because we have a lot of data with the onset of social media and the ubiquity of mobile phones. So we experiment with 5 neural network methodologies. 3 of them were pre-proposed in literature, and 2 of them we have come up on our own because so they're more adapted to our dataset and to our problem. So we start with a word vector embedding model, which tries to assign an embedding to every token such that we can capture the semantics of the language in these embeddings. We train by trying to predict the context of a set token. And this was our first initial model. After that, we realized just working with tokens doesn't work so good because we need to generalize out of the tokens we are seeing, because we cannot see everything always. So we need to somehow include characters. So we do the same kind of training with characters, and then we combine the both to work with that. But it turns out that the variety in the usage of characters is too high for us to get some good embeddings out of them. So what we instead try to do is that we have a token, we get embeddings for every character, and then we combine those, we average out them, and then combine that said mean pool thing with the token embedding, and hence get a final embedding which we use to encode the semantics of the language, right? But then again, so like an example would be that the word in India and the word in the characters in working, they have different importance, because in working they give you they have some morphological advantage which would help us infer the semantics. So we need to give more importance to some characters, but we cannot encode all of these rules, because so what we try to do is we automatically learn something called attention, which helps us give more importance to some characters and less importance to some others. And then we do this combination. And we try to work with that, and this is one of the best models we have proposed. And one other pre-proposed model was that, so our embeddings till this point for every character were not aware of the characters that are around them, right? But so we try to build models that have some memory elements that remember the characters that are before them and after them, and then they combine them to form the final embedding for a character. Then we again apply attention over them and get the final embeddings we try to work with. Seeing this, these are our results on the Nepal dataset. On the neat tweets, we get a 57% precision, and we calculate something called an F score, which is a balance of precision and recall, which we reach as high as 4.462, and this is by one of our proposed models, the attention models. And same thing we see for the availability tweets for Nepal, which we reach as high as 84%, with our F score as 0.488, and something called a mean average precision map value is 0.335, which is not so high but okay to work with. The only problem here is that most of these models take time to train. So by time I mean something like 6 hours. So we would like to work better than that. So we attack something called reusability of embeddings, so that we have seeing past events, we train some embeddings on those past events and try to adapt to the new data, so that we have to do less amount of training, and because time is of the essence during a disaster situation. And we also sometimes see that the data during a disaster is quite noisy, but the data we might have before may be more filtered, less noisy. And in one data set over the Italy quake, we see that our precision was just 12% initially, but after adapting our Nepal dataset to the new Italy dataset, we go higher. Again, it is not so large, but we are still doing better than we were before. I would pass on to Ritam now to discuss the rest of it.
Hello. So having seen how we are extracting the needs and avail tweets, it becomes important for us to extract the information present within the tweets as well. So we have devised a framework or a model which will try to categorize the information present inside the tweets into these 5 categories. Resource, which talks about the specific resource present in the tweet, the quantity of each resource, the location where the resource is needed, the source, that is the organization who is offering the resource or who needs the resource, and contact, the person whom to contact for the particular resource. This is in case a phone number or a mail is given in the tweet itself. Now, I need to stress on the fact that this template is common for both need tweets as well as for offer tweets. Now, we use standard NLP tools and techniques to extract this information, which are included a part of speech tagger, a named entity recognizer, a dependency parser generator, and also a dictionary, which is specifically the WordNet dictionary for looking up for similar resources. Now, to identify this specific information from the tweets, we observe the semantics as well as the structure of the sentence in order to infer what can be a possible resource or quantity. So I'll tend to illustrate, for example, a resource can be whatever object or subject that follows a need or a send verb. All right, and a quantity can be any number modifier of that particular resource. So I'll explain that or illustrate it better with this example. This is a well-formed overt tweet whose information can be extracted by our algorithm. It says that Parkland Hospital, Pokhara is providing free medical treatment to earthquake victims. Contact Dr. Shiva Prasad Prajuli and his mobile number. Now, the resource is medical treatment because it is the object of the word provide, which is the root verb in this sentence. And also, the location is shown to be Parkland Hospital. This is because Parkland and Pokhara is identified as some proper noun by our named entity recognizer, but more important thing is that Parkland is followed by hospital. Now, usually named entity recognizers can either fail for or rather mistake this location for some person or organization, but in this case, having the word hospital in between it lets us know that it's actually a location or a building rather than a particular person. Likewise, Dr. Shiva Prasad Prajoli, since it is not following or conforming with the rules of location, it is classified as a source, and the contact number is just obtained by regular expression. However, this is a well-formed tweet, but we do face problems if the tweet is expressed in a very roundabout manner. For example, here it clearly mentions that people are staying outside. However, it's difficult for the machine to recognize that outside would correlate with shelter, that they need tents or tarpaulins or things like that. So although the other fields are properly filled, it becomes difficult for our technique or algo to directly infer that tents are being needed out here or being stated out here. So provided we get a good understanding of how to extract this information, an important part of our project was to assign the need tweets with the offer tweets. For that, we proposed some techniques in order to match the needs and the offer resources. For this workshop, we have only considered on picking out or extracting the list of resources which are mentioned in both the offer and the avail tweets and matching with respect to that. So for each need tweet, we get a list of resources, and for corresponding to those list of resources, we get a list of viable offer tweets which are ranked in decreasing order. We take the top 5 of them. Now, how we match that technique, we've used 3 techniques. One is simple pattern matching after doing some pre-processing on both the resource lists and the needs and the offer tweets. But it fails in case the need, which is say tents or shelter, if the offer tweets does not have that exact word, that offer tweet cannot be assigned to this particular need tweet. So in that case, we choose WordNet as a dictionary so as to find out some similarity between resources in case there is no exact string match. However, since WordNet just looks at direct semantic analysis and is just a lexical based approach, it doesn't yield that good results, for which we were motivated to use word embeddings that were trained on previous examples to find out the cosine similarity between the needs and the offer resources. And as can be seen, that the precision and the recall of the string match with the word embedding model performs better than that of WordNet or simple pattern matching techniques. And an example to ensure that, to let you know that word embeddings do perform better is here. The given resources which were taken out here were orthopedic or neuros, anesthetics, but these are very specific medical terms which might not be available in the offered tweets, as a result of which they fail in the exact pattern matching techniques. But word embeddings are able to find out skilled emergency surgical teams, which shows some level of precision. And now I leave it to Shreyash to talk about the design of the system.
Hello everyone. So as we are designing a system for a disaster scenario, people during the disaster scenario, different stakeholders are actually going to use the system. So it was very important for us to understand these different users. So we conducted some long interviews over telephone. So we did interviews with doctors, one practicing in government hospital, one practicing private clinic, two volunteers, one who managed or helped during food sourcing and making, one who did food distribution. We managed to get one interview with an experienced rescue volunteer who worked with the NDRF. And we also took one interview with the team Mapbox, who actually built a crowdsourced system, the Chennai flood map. So through these interviews, we got a lot of data, and we categorized the data into different categories and found some interesting patterns in the categories. And we got some insights which helped us design this system. So I'll just go through the important insights which we got. So we had to use a map-based system as different needs and offers are very location-specific. It was very important to show different vulnerable locations, different important buildings like schools, hospitals, old age homes, where the disaster could affect. Those are like vulnerable localities. Also, we with respect to the relief and all, so the relocation camps is very important, as most of the needs starts from these relocation camps with respect to food and water. And so just after the disaster, the medical checkup camps is very important to avoid any epidemic spread during or post-disaster. So medical checkups are very important. So this is with respect to the map-based interface. So providing platform to the local volunteer to find the nearby needs. So during one of the interviews with the volunteer, what she said is that, I know my street, but I don't know what is happening in the rest of the multiple streets in my own area. If someone needs help, how will I know? And where should I start? So she was a volunteer who was delivering food in different places, but she didn't know that who actually needed it. So a system where, or interface where the volunteer can understand where all the needs are is important. One of the important challenges which we understood is understanding the credibility and verification of the need. So I try to understand how did they actually manage in real, so that we can take inspiration to build a digital system. So one of the things was, when there is a number to a particular need, then they consider it as more credible. But we cannot completely rely on this because the data is quite limited. And another thing is that whenever the representative went and delivered the particular resource, he actually saw what the situation is and then only delivered a particular amount. So abstracting this kind of insight, we thought of having, like, let's say, after the need comes, it's a new need. Then it is assigned to a particular volunteer. The volunteer verifies that particular need, and when it's completed, it will be marked as completed. Also, as being told before, there is a set of people who are not on, who are like off-site from the disaster location, who really want to help, who might be friends, family, or people who have immigrated to some other place or something like that. So as we understand that the algorithms can be limited with respect to multilingual mixed coded tweets and all, so we thought of using these remote volunteers to do annotations and categorizing these tweets into different categories, as Rhythm has shown. So the final insight, the main important part was different stakeholders like victim, remote offsite volunteers, the ground volunteers, the NGOs, the government have very different contexts, have very different needs, and have very different expectations. So they have very different mental models. So we cannot design one thing which all of them can use the same thing. So we thought that it has to be a one system, but it should have different interfaces which are designed and suited for their particular need. And now I'll talk about the design prototypes which we made. So we designed interfaces for three categories: the control center, the remote volunteers, and the ground volunteers. So initially we did some paper wireframes. We had some internal team discussions of how the information architecture should be, how the interactions should be. Then we made this first version of our prototype, and so this was completely sitting here and making. So we thought that this is actually going to be used by people out there who are stuck in a disaster. So we actually wanted to see if we give it to people, what do they understand from this interface from the first go? So we did some usability testing. So I went to Chennai last weekend. So we did some usability testing. It was a very small number, but it was just a one-day testing. 2 doctors, 2 volunteers, and 1 victim. So during a usability testing, we take kind of a prototype where we give tasks telling that how do you do this, how do you do that, and we see how they actually do it. So from that, we understand how our mental model and the user's mental model differ, and we get insights of what all changes needs to be there in the system. Then with these insights, we redesign the system, and this is like the final version of the 3 systems, and we'll play a short video.
So this video is about the final system which we dream to build one day. Only parts of it has been done.
The dashboard is meant for government authorities and volunteer organizations. There are needs and offers in different areas. In needs, it shows the government relocation camps placed at government schools, temples around the affected area. The specific needs like food, water, electricity, rescue, and medical for different people are shown with their personal phone number and the location. Any emergency situation is marked with an alarm and as a priority case. For an organization that is providing food and water can uncheck all other needs and focus on food and water only. Inside a particular need, there are many more details about the quantity and a progress bar which tell the status of action of a particular need, whether it is a new need or assigned to an organization or verified by the organization or completed. The need is matched to the nearest relevant offers. In this case, this is a new need and is not yet assigned to any NGO. There is a comment section to discuss and check the credibility with the ground volunteers. In offers, the offers provided by different volunteer organizations and individuals are shown. It also shows health camp set up around different areas to offer medical facilities to avoid any epidemic after the calamity. Inside a particular offer, the nearby relevant needs are shown so that the organization can be assigned accordingly. The volunteer can see all the nearby needs in his locality. He can select any one need and see what is the need about, the phone number, the contact person, and the progress tag. Inside a particular need, he can see specific details like quantity and the nearby offers. By accepting this request, this need gets assigned to this particular volunteer. Once assigned, this need won't be assigned to any other volunteer, so repeat delivery would not happen. He can verify if the need is credible, as it is in his own area, and deliver the particular resource. On delivery, he can mark the need as complete. The remote volunteer can help the system to function better by assisting the algorithm to extract the right information from the tweet. This particular tweet is a potential offer, but airlift has been wrongly added in the resources. This can be removed by the volunteer. Once the other information is verified, the volunteer can submit. Whichever fields were empty, the system will auto-generate a tweet back to the same user and ask further details like contact and location, like in this case. And similarly, this kind of a manual verification could be done to other tweets like non-English tweets and code mixed tweets.
Okay, so that was the video, and so if you yeah, so if you understand, maybe this, the right hand panel which shows the different tweets with the contact numbers and all, we hope those would be filled in by the algorithms that we are designing. So of course this is a dream system, we are yet to reach this kind of accuracy, but we hope to get it. So I'll just quickly summarize the future direction. So till now what we have seen is we have worked on these 3 modules in this workshop: the identification, understanding and matching, and we have designed a possible interface. Of course there are design challenges too. Lot more things need to be considered to get a good design. In fact, all of these should be improved. So let me just point out some future directions. So till now we are using this retrieval model in getting these need tweets and availability tweets. But what would be more practically useful is to go towards the classification framework, which would be real time. That means as the tweet comes in a stream, for every tweet a decision is taken as to whether it's a need tweet or an availability tweet or something else. So till now we do not have enough data to train a classifier, because a neural network based classifier will take several thousands of tweets to train. Still we do not have that many need tweets and availability tweets to train. As we saw, like these 2 datasets combined have only few hundred of these tweets. Okay, so next is the understanding part. So till now all requirements or all needs or all availabilities are given the same weightage. But that's not true. In a practical scenario, there will be some more critical needs. For example, some needs come from the actual disaster site. Whereas, so for example, if you see these 2 tweets which I have pasted here, it says here, so blood crisis here in Kathmandu. This is clearly coming from that area. Whereas some from outside just might say that, oh, Nepal needs a lot of blood and food. So there's a distinction between tweets which are coming from the area versus outside. So this kind of prioritization of tweets and all need to be done. So as I told you, Aditya is the linguist. So she is trying to figure out some linguistic cues to figure out which tweets are coming from the area, or maybe which tweets are being posted by a victim, those kind of things. Next is the matching. So as Ritam told you, till now we have only considered a match to be correct if they mention the same resource. But again, there are good matches and there are not so good matches. So for example, if there is a need of water in Kathmandu, maybe a good match would be water being available in Kathmandu and not somewhere else. So those kind of, like, we want to improve the matching by considering things like, say, geographical proximity of where the need is and where the availability is. We have not done that yet, but we hope to do these. Also, there is a question of immediate actionability. For example, if the need is of drinking water, someone might say, oh, India is sending 1 lakh bottles of Indian water. That's not immediately actionable. Versus if someone says, we have 50 liters of water in Kathmandu, that's immediately actionable. So those things we could improve. Next, also we have understood from the video you saw that different people have different mental models and they want to see different subsets of the situation. So we want to have this a classification and summarization module, which will possibly show different summaries to different stakeholders based on what their interests are. For example, Red Cross might be only interested in medical needs, whereas maybe the army might be interested in people trapped or roads damaged. So we want to classify those kind of information and show different summaries to different people. Again, as I told in the beginning, in this workshop we have only considered English tweets, but as we saw from some examples, when there is a disaster in, say, like India, there are a lot of tweets posted in Hindi, Tamil and also code mixed tweets. So you would like to extend our algorithms for those kind of tweets. We have taken an initial step. So there is this conference called FIRE, Forum for Information Retrieval Evaluation. It's organized by the Information Retrieval Society of India. So every December is the conference. So we are organizing a shared task in collaboration with Monojit here. So there we have almost the same kind of problem, like identifying and matching need tweets, availability tweets, but we have not only considered English tweets, but also the challenge is about considering tweets in other languages and code mixed tweets also. So we hope to get some good solutions, and we also are improving our own solutions. Finally, one thing that we have understood through this exercise is that however much we try, not all, everything can be automated. For example, there will be always some tweets which are written in such a roundabout way that algorithms cannot understand that. We have seen examples of such tweets. Then verifying information is often very difficult to do using an algorithm, like understanding rumors and all. So for that again, some manual intervention might be necessary. Another important point, so for all these, so we envisage that the system will have a module by which, say, people at the control center or volunteers can actually talk to people on site. It might be either over phone or over Twitter, but some mechanism must be there to contact people on the ground. Another important thing which we understood through the discussions and all, that many people post about needs, but very few needs are actually closed. That means when the need gets satisfied, no one informs that. So there is repeat delivery and these kind of problems. Therefore, this also possibly some human intervention is needed. That's why if you saw in the video, we had these things of talking to volunteers and all, or utilizing off-site people for helping the algorithms with some manual intervention. Okay, so that's more or less about the system. So a goal of this workshop is to make the data and codes available to the community. So we are already making most of our data and algorithms available here. And we have already submitted one submission. So the retrieval part of identifying need tweets and availability tweets, we have the deadline was this Monday, the last Monday. So we have submitted to the SIGIR workshop on neural information retrieval. So the paper is here, you can take a look at it. And also we have other planned submissions, for example, the matching part, that also can be published, and also the user, from an HCI perspective, maybe the user studies and the system design, that also through the interviews and all, we have got some insights which could also be publishable. Additionally, if we go on working on code mix data, as we will do in this shared task, those can also lead to other publications. So I'll end here saying that a small part has been done, but at least we have understood that there is a need for urgent need for this kind of systems. I mean, actually we have been told that NDRF and all need this kind of systems. So we hope to continue improving the algorithms in future. Thank you.
Yeah, so I was just actually reading your related work, but I've seen a couple other systems like this. I think mostly for people location. That in disaster they're trying to help find people. So maybe you could talk a little bit more about how this is unique from a lot of those other systems.
Yes. So some of the systems we know. For example, Ushahidi is one system which was developed during the Haiti earthquake. It was an SMS-based system. Then we know of a system called AIDR, which is being developed in Qatar Computing Research Institute, AI for disaster response. So I collaborate with them also a bit. So, but in talking with them, we have understood that a lot of things have been done. For example, summarization or classification of some kind of information, they have been done. But in general, this specifically identifying and matching needs and resources, we are not aware of any system which actually does that. So, so in talks with the people of Qatar also, they told that this would be a good thing to incorporate into the AIDR. So the AIDR is used by UNO also. So they also agreed that this might be a good module to add to it.
And also, I guess you presented two different extremes. The first was highly unstructured Twitter, where people are just saying what they need and trying to classify that. And then the other extreme was an app where you're explicitly trying to. I'm just wondering if there's kind of a hybrid, because also obviously in a disaster scenario, you may not be. May not have the app. You might just be, trying to understand your situation, trying to understand what's available. So is it possible that you have, almost a conversational agent that helps push people towards, what is available? Because if you're in a disaster, you may not know water is there.
Exactly. So that is why you have this contact for volunteers. So this is meant to be a chatbot kind of thing. For example, if someone has mentioned a need but has not mentioned where, so the chatbot can actually ask that where are you, or someone said I am trapped. So during Chennai floods, we actually see tweets like, oh, me and my family is trapped here. But in their anxiety, they forget to mention where. So this chatbot can actually talk back to them and get that information. Also, we agree that, so tweets would be unstructured. They are inherently like 140 characters and all. But we also intend to have these mobile interfaces by which maybe the people at the site, they can actually enter clean data. So we can actually tell them to fill up the template that we showed. Resource, category, locations. So we'll try to extract out things from the tweets, but we can actually have cleaner input by direct inputs from the people. So sure, it will be a hybrid system, because in such a scenario, like any data is valuable, and you cannot think that we'll use only one medium.
You said you went to Chennai to have the system looked at. So was it in some sort of mini disaster scenario, or was it in a non-disaster scenario?
No, of course, non-disaster scenario. So, uh, so the so the volunteers who had worked during the Chennai floods and the doctors who had helped in the medical camps during the Chennai floods. So I tried to do the usability testing with them. So I understand that there are a lot of limitations with respect to this because it's not in scenario interviews or research or usability testing. So the insights will be quite limited from that perspective.
Yeah, and the reason I ask is if you, in a disaster scenario, I would think that the first 24 hours is critical.
Yes.
That's when the rescue operations, the immediate, emergency needs, food needs, shelter needs, all those things come about. And so, how does the system become intuitively used within the first 24 hours anywhere in the globe? Because not everybody's trained to use this system, and so how do you scale it?
So I would like to take that question. This is an exact point which have been pointed out by some government people also. So they say that if you have a system which can be only used during disasters, it won't be used because no one has that training capacity then. So try to build a system which will be used for some reason throughout the year. Maybe if during a disaster it becomes specifically for needs and availabilities. But one suggestion we got that even in the city, there are needs and availabilities all the time. Like from cabs to many other things, there are many things needed. So they also told us try to have a system which people will use throughout. Then they will get accustomed to it. Then maybe during a disaster it will be actually adopted. But I agree that's a challenge. So things like keeping the interface very simple, those things can be helping. But I agree that during the first few hours it's difficult. But at least maybe the relief workers and all can be trained a bit in advance if we can get some collaborations with institutes who train this kind of workers.
So there were like two bigger challenges. So during the Chennai floods, half of the people interviewed, they said that the communication was completely down. They didn't have network, internet, and etc. etc. So again, it's tricky. I understand that. But some volunteers, so they said that there were patches of area throughout Chennai where the internet was quite working well, and they actually they used to go every 1 or 2 hours over there. They used to get updates and used to manage through that. So I think there's still some scope, and what I got is that during the disaster scenario, the phone call lines get jammed, but the internet still works. WhatsApp, Facebook, and all is still working. So there is still scope, I feel.
The other question that I have is, I think you mentioned it, maybe 3% of all the tweets during a disaster are related to need-based, and some of those tweets are incoherent in the sense it says I'm thirsty, I'm staying outside. So those are, if you infer, they're still need tweets. And so I think the system, would only address in the event that they have an internet connection, they're able to express themselves in a very particular way, and it works in the scenario. I've also seen scenarios. I was in 9/11 in Manhattan at the time, and there were a lot of missing people queries. Is my relative still okay? Where's my relative? I need to call back and check in. Does your system in some way figure out how to do people finding? I know there's a rescue aspect of this, but within a disaster scenario, there's a big need for relatives and friends to know where the location of a specific person. Does this system somehow address that?
So we have not tried to specifically solve for that, but yes, that is definitely an important category of needs. So we'll have to check if the system automatically detects those things. But I can tell you one thing that, if we so these models which are trained, if we get some data from previous disasters, which are like these of the tweets that you mentioned, then the models, I would expect them to get trained to finding those kind of tweets also. And so the missing, so as I said, so this is a point possibly we didn't think of during making the video, but sure, if there's a disaster where a lot of people go missing, then there can be parts of the interface which are actually dedicated to that.
So recently there has been in middle of this month only, Facebook came out with something called extension to its graph for disaster relief, and they specifically give you information that. So we plan to incorporate that in a system. And so with people finding Facebook would work better because with Twitter, Facebook is more connected that way, and they already have a lot of modules in place. So if that can be directly called by our system, that would take care of the missing people part, I suppose.
So what you have addressed is one building block of an overall control and coordination system for disaster management.
Yeah.
So have you looked at integration issues, how you integrate whatever you have done with an overall system which will take care of the end-to-end disaster management operations?
I can't say we have done that yet, but I've been talking to people at QCRI who are building, they have this AIDR system that they have, artificial intelligence for disaster response. They have been working, so that's almost a complete system because UN people use it. So if we can, so sure, this is just work started, but I think that if we can get the accuracies and all up to certain level, we might try to integrate that with that. But I agree that, I mean, what new challenges that will bring, that integration, that I mean, maybe there will be new challenges which I am not being able to visualize right now.
So the other question was, this matching that you are doing is very interesting, but I believe it will involve a lot of operations research.
Yeah.
Right? Because if you have needs and if you have offers, matching will have to take into account the locations,
Yes.
the logistics.
Yes.
So there may be some OR issues.
Yeah. Sure.
Have you tried to formulate some
Not yet,
optimization
but as I said,
problems?
so we understand that the matching
it will
needs
be a
to
terribly constrained optimization problem.
Yeah, so you are right. So the matching needs to be improved a lot because also apart from geographical proximity and all those things have to be there. Additionally, the time factor also comes in. Maybe a need is expressed today evening. There is no point in matching it maybe tomorrow evening. So you are right that how much is needed, when it is needed, where it is needed. These things should go into design of an improved matching algorithm. Of course, I mean, so one thing is true that possibly, I mean, it would be a bit ambitious to think that this system will do the matching, but this system can actually indicate some potential matches considering these things into account. But I think the final decision will have to be taken by someone experienced in disaster relief. So that is why we think that there will be a control center which is trying to help, or at least the volunteers who are in the area are getting updates on their mobile phones that these can be potential needs which you can match, or these can be potential availabilities. But I agree, operations research should be incorporated here.
Okay. Also, the data that you will be working on is essentially online, lot of streaming data. So all the algorithms that you are going to use will have to take into account the online nature of the problem,
Sure.
right?
Yeah.
Yes.
So that is the next step.
So that is why I said that we want to move towards a real-time classification framework, because then, I mean, for retrieval you have to have first a set of tweets, and maybe even if you use pre-trained models, still, I mean, that can be done after some tweets have come. But if we want to do it real time, that means as soon as maybe some disaster has occurred, we want to get the system working. For that, we want to move towards this real-time classification, which will use pre-trained models like the ones we are using here, but maybe not for retrieval from a large set of tweets, but to classify each individual tweet as it comes.
So I was wondering if we sort of turned this problem slightly and we asked in the aggregate information, is there need for food in Bisan Nagar, for example? Whether, because now you don't want to, every individual tweet, your accuracy is not going to be important. In the aggregate, are you able to express this information with much greater accuracy than you would be able to do on a per tweet basis? And since the number of resources are limited, maybe you would get much higher accuracies on the system than with every single individual need. And you could also probably graph this over time and say, there is a need at this time, and then it's dropped. That might be something.
I agree.
And the absence of any tweets could be sort of like a blackout zone. This sort of signals. It's the second point I want to make.
Okay.
And the third thing I wanted to ask is that you're using Twitter data, but we're not talking about any of the Twitter specific things. We're not talking about emojis, we're not talking about hashtags, we're not talking about verified accounts. Probably easy to identify people that are actively tweeting about disaster relief, and so that might be like a verified stream might be something that's from certain journalists, for example, or people on the area. And if you categorize certain people as they're tweeting about this and they seem to be tweeting verified stuff, and let's pull all of their tweets into this system, that might be something that's...
So thank you for the suggestion. So while at MSR, I mean, in hindsight, I realized that we should have done this study on Chennai floods, because in MSR itself we have met several people who are working on this Chennai floods. So we actually have come across a work which tries to see what the roles of different people were during the Chennai floods. And as you said, they found some journalists or some celebrity accounts, including movie actors and all, who had taken up different roles. So maybe some movie actor, because of the influence that they have, they were trying to do kind of what the system tries to do, that to understand what is needed where, what is available where. So I agree that so you are right. So in this, what we have done now, we have only worked with the text. We have not considered the users. There are challenges there also, because I know about some studies on rumors which say that in such a situation, even verified accounts post rumors because everyone is under stress. So it's not straightforward, but I agree that some important people or verified people, we could take advantage of what they are posting, or maybe, if we can. So another problem which is orthogonal to this, but sometimes communal things are posted. So in another work we had this idea of whether we can encourage some influential people to post some anti-communal stuff, so to counter those kind of communal posts.
The other interesting thing from this I see is that this possibility when you're using Twitter of actually social engineering, that is to promote certain hashtags for people that need something, or to promote something for people that actually want to ask, and then you use a bot army to actually promote these tweets, and then I mean your information will start to get more.
So
more
one
accurate.
idea which we have, a far off idea still, is that this bot that I told, a social bot. So suppose if someone has posted a need very covertly, which human beings can't even understand it's a need, or maybe a human being can, but normal searches which organizations do will not get that, then the bot can actually post a well-formed version of that, or at least even if through human intervention, if it is understood that there is this need here, but it has not been expressed, or it's not given enough coverage, then the bot can actually post on behalf of it. And so it's true that organizing information, for example, saying that let's use this hashtag to indicate needs, let's use this hashtag to indicate availabilities, that can be a good way of organizing information.
And you can actually push that via the system.
Yeah. So I agree. So these are definitely, thank you for the sessions. These are definitely we had in mind, but sure, we would like to get to these in future. Thank you.